Okay, do you recognize any of these symbols? Pi, what's that one? 3.14. Give me something else you know. 0, 0, good. Woohoo! E, about 2.7, special number found in nature. We're going to talk about it a lot today. It will be the answer to one of my important questions of the day. I is imaginary, which stands for I, which is square root of -1. Very good. Does anybody know that one? It's a really powerful math symbol. It's called phi. Anybody know what it is? All right. It is called the golden ratio. Golden ratio is this amazing ratio that makes the perfect rectangle. It's 1.618. If you divide the longer side by the shorter side in a perfect rectangle, like this attitude poster here, if it was the golden ratio, when I would divide this side by that side, it would get 1.618. Why do you care, you say? Because out of all the rectangles in the world, that one was considered to be perfect. So most of ancient art, and in Greece where they were, you're not on a cell phone, are you? Good. Oh, that looked like a cell phone to me. To put it on my desk, please, we'll have a little chat about it later. All right, now, the number I was trying to tell you there about phi is this ratio, and it's also found on you, on the human body. That's why the people who were making the art and making the buildings in ancient Greece were so jazzed about this number, because it's found on the human body no less than like 45 times. I'll give you one instance of it. Hold your arm out. Look at the distance from the base of your hand down to your elbow, and the distance from the base of your hand to the top of your hand. Think of them as two distances. You take this distance and you divide it by this distance, and you get 1.618. And that would just be kind of ho-hum, except that it's also found. Take your height to the floor, take your belly button to the floor, divide those two numbers, take a wild guess what you get. 1.618. Take the distance from this way across your hand and this way across your hand, divide the two numbers, what do you think you get? 1.618. And it was found at a staggering number of places. It's almost like a little signature on you. Think of it this way. An artist like Renoir or Van Gogh or Monet, somebody who's really good at art, they can just look at a painting and say, oh, that's obviously a Renoir, or it's obviously a Van Gogh, because of how it was done. It's like the signature style. So the signature on you seems to be this 1.618 number. It's still all over the place. I'm telling you, like, if you turn your head, I'll give you one more. Turn your head to the side. You don't have to turn your head to the side. But if I turn my head to the side, and if you were to make a rectangle around my head like this, okay, and then you find the distance from the front of the rectangle back to my ear, and the front of the rectangle all the way to the back of my head, and divide those two numbers, 1.618 again. It's all over the place. You can get the picture if you want to, like, Google this and Google it for pictures. You could find pictures of the human body with all these ratios like laid out on the human body. It's just mind-boggling. I know what you're saying. These can be off a little bit, and you know what? Just like there is like the perfect face, and if you're off from that, it looks off a little bit and doesn't look as beautiful. Okay, the more off you are from the ratio, the more goofy looking you are. I'll give you an example. Say somebody has this, like, their belly button's like up here. Wouldn't that look really weird? Why? Because you're used to seeing people's belly buttons in the right spot. Okay? See what I'm saying? So if it's off a lot, it's going to be noticeable. It's going to throw off the 1.6, and it won't be 1.618 anymore, and it will look kind of strange. All right, so anyway. Now, it's talking about some of these numbers for fun, because there are lots of amazing numbers out there in math. It's not just pi, which is kind of cool, but there's so many others. that you can know. Now we're going to talk a lot about this one today because E is really important. When we graph this thing, I hope you remember that it looks like this. Remember that? All right. What's its twin sister? I told you like 4 times last week. Upside down one, yeah. What's that one called? Log. There you go. It's like this. And if I made it a reflection over a line, can you picture where the line would go? And that was over the line y equals what? X. And this one's graph is y equals e to the x. And this one's graph down here, the black one, is y equals ln x, the natural log. All right, so you've got these two are inverses of each other. And they're inverse because they're a flip over that line, y equals x. That's 3 of your big 12 functions. The reason I kept pounding on that is so that you'd be more comfortable today. You're going to find that a lot of the stuff I did with you last week, you were like, it wasn't even on the test. Why are we teaching this stuff? That stuff? Because you need it now. And if we tried to do it all today, you'd be totally lost and burned out by the end of the day. All right. This is just one more, example of where E comes from. E is about 2.7. And if you do this simple interest example, he was playing around with interest and he was saying, what if we did this, 100% interest, which would be like 1 plus 1. We did that last week, right? And this would be 50% interest. Would it be better to get 100% interest and have 1 compounding time? Like at the end of the year, they double your money. Start with $1, you end with $2. You get how that worked? Starting values here, ending values here. And it's 100% interest and it compounds once. Or would it be better to get 50% interest and compound it twice? And what does it turn out? The second one's better, right? See how they're $2.25 if you do this one? So basically, you want a bank to compound your money as much as possible. So how about 25% interest, and we'll do it 4 times a year. That should be the same thing as 100%, but it's not. You get even more money. So then they said, okay, well, what if we divide this up into 12, like once a month? And this is how much you'd get if you take the interest and divide it by 12. 12 times 12 compounding periods, you get even more money. So what is this? What is this? This is where it's compounding every year, and it's the interest that you'd need to make it compound continuously all year long. Like it's constantly, they refigure out your new interest and refigure out your new interest and refigure out your new interest, like constantly. Instead of just like once every month. Most banks do it like once a day. Well, this E comes up in that calculation. I don't expect you to totally understand that, and I really don't expect you to understand this, but it is true that E is equal to that continuous fraction. It goes on forever. And that's why the number goes on forever. 2.718, blah, 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 blah. I don't know how they figured that out. Some really smart mathematician guy figured that one out and probably proved that it was true, did a proof. But I don't know. I just found it on the internet, thought it was interesting. All right. Remember I was talking about all those fraction exponents? They're going to come back now. There's a reason why I needed you to learn those things, and it wasn't because of the last test, it's because of what we're going to do now. All right, so remember how I was saying to make it smaller before you make it bigger? Remember that little phrase? All right, so this, you're supposed to take the 125 and make it smaller first, and then make it bigger. You break up the 1/3 and the 2. If they multiply together, they make 2/3, so it's still right. Could you stop with the cracking the bottle? Thank you. Okay. 125 to the 1/3 is 5, and then you take 5 squared, and that's what? All right, 25 is the answer for that one. All right, would you look at this one, please? Don't just look at it. Take it, write it on your paper, figure out what the answer is based on what I just showed you there. Can you move your backpack to the floor, please? Thank you. All right, hopefully you have 8 to the 1/3 to the 4th. And hopefully you know what 8 to the 1/3 is, like that. What is it? 2. Because 2 to the 3rd power is 8. So 8 to the 1/3 power is 2. So 2 then to the 4th is 16. Raise your hand if you had 16 on your paper. Good. This one, could I rewrite that? Actually, let's do this one first. Could I rewrite that as 125 to a power? Yep, to the negative 1. 125 to the negative 1st power. Look at this one. That could obviously then be 64 to the negative 1st power, right? But can anybody think of a smarter or a different way to do it that still would work? What do you think? Let me check. 8 to the negative 2nd. 8 squared is 64. The negative makes it flip. You got it. It's just different. It's not really better. It's different because later in this lesson, you're going to need to match bases. You're going to need to make like one side have a base of 8 and the other side have a base of 8, and then something like that would come in really handy. What if we really wanted to write it as 2 to the something? What would it be? 2 to the 5th is 32, I'll tell you that. 2 to the 6th, but then it's got to be negative. You got it, 2 to the negative 6th. How about that 125? Now all of a sudden, there's all kinds of ways you could have written that. Give me one way. 5 to the what? Negative 3rd, very good. 5 to the 3rd is 125, and the negative would make it flip to 1 over 125. All right. Let's talk about that for a second. What's the answer? 2. Now, if I did the cube root on both sides, do you get how that would be cube root of 8, which is 2? Is there another way I could have shown my work? Taking a cube root is the same as if you had done what? 1/3 power. You're getting more comfortable with these fraction exponents, I hope. All right, how about this? How about if you remember when we were doing this, and I said over and over, when you go like this, you get the absolute value of x equals 4. That way you'll know there's 2 answers, plus and minus 4. Does that ring a bell? Remember that? It was like 3 tests in the first quarter that, or first semester that had that on it. Kept happening. Kids would keep on saying, oh, square root of x squared is x. No, it's not. It's absolute value of x. And then you get 2 answers, plus and minus 4. Why? Because the original problem was this. And doesn't negative 4 work in there? Yes, it does. So when you take square roots, you got to be careful and put absolute values. Do you have to do that with cube roots? Let's look. If I do cube root, I just did it right here. Did I get the wrong answer? No. Is there another answer that would have worked? No, because negative 2 wouldn't have worked. Negative 2 times negative 2 times negative 2 would be negative 8. Okay, so that wouldn't have worked. So bottom line is you don't have to worry about those absolute values there. But you do here, and it's going to come back again, and some of you are going to get it wrong for the 3rd time because you're going to forget that the answer is plus and minus. So be careful. Yes? Good question. If it's to the 4th power, does it need absolute values or not? Yes, it does. 5th power? Nope. 6th power? Yup. Anytime it's an even power, it needs absolute values because there'll be 2 different things that would work. All right, moving on. You've learned to solve many, many kinds of equations, and this is one of them. I'd subtract 3 from both sides to solve the black equation, right? Okay, how do I solve this? Yes, it will be a plus or minus. You're going to have to split it up into 2 parts and go x equals 7 or x equals negative 7, right? Okay, how about this red one over here? How do I solve that? Divide by 3 and it'll be 7/3. How do I solve the blue one? Square root, and what's the answer? Ooh, all right, I heard it. Plus or minus the square root of 7. Because when I go like this, it makes the absolute value thing. Don't forget, you got 2 answers for that. Okay. So, how do you solve the green one? It'd be nice if we could undo this somehow. There's always something to undo everything. To undo x in a power like that, we need to use logs. Now what I was having you do, and you got pretty good at it, was graph this side, graph that side, see where they cross, right? We did that like 10 times, and then on the R4 question, which some of you guys wussed out and didn't even try, if you would have tried it, you could have done it. They would have just put an R3 next to it. You would have thought, oh, I can do this. Okay, because many people that tried it got it right. So congratulations, a lot of you. You included. Nice job. A lot of 4s on this test. Not tons, but a lot more than normal. All right. So, yes, I could graph both sides and see where they cross. That's an option. But there's a way to do this with logs, and that's what you're here to learn today. If you knew how to do logs, that would be the answer. Now, I know right now that just kind of looks like Greek to you, but write them down side by side, please. And I'll show you how to get from the one to the other. What we want to know is what number can I put 10 to that would give me 30. And if you do the log thing right, you'll get an answer of 1.4771. And 10 to that power is 30. But that comes from this. Now, how the heck do you get this out of this? How does that make that? I'll show you. First of all, we need to know how to say it. Remember on the limits, I was driving me crazy when people wouldn't say the limits right? Got to say limit of the function as x approaches infinity equals whatever. You got to say it in the right order, otherwise it just sounds wrong. At least to the person who knows how it's supposed to sound. So these, kids have trouble saying them too, so I want to make sure you know how to say it. If I was going to say this to you, I'd say log base 8 of 5 equals 12. This little lower number down here, that's called the base of the log. And the argument, you don't call it the argument when you're saying the answer, but this is called the argument. And this last piece right here, the one that's on the outside that's all alone, this one here, is the exponent. I know you don't understand why that's an exponent yet, but it is. If I were you, I'd write down this one right here in your notes. Because you're going to be asked for, what's the argument in this problem? And you'll be like, what? Unless you know and have memorized the positions. Okay, a lot of times they're written like this red one here. And they don't have an equals, and they don't have anything on the other side of the equals. That's because it's a number. And they just don't know what the number is. So you could always, and I strongly encourage you to do this on today's homework, the first like 12 problems are all like this. They don't have an equal sign. You should put equals x after them. And notice when this smartboard was made, the teacher even said it even though it wasn't there. Log base 7 of 24 equals x, even though there wasn't an equals x there. Okay, so if it doesn't have anything with an equal sign and something after it, put one in. So to see if you really understood that, this one right here, Mr. C in the back row underneath the fish. Say it. You keep looking down. That's all right. Just fight through it and you can do it. Log. What do you think that little 2 is called? Uh-huh. Log base. You got to say the number. What's the base? Log base. Yep. Good guess. And if I had it to do over again, they would have said it that way because they don't ever say the word argument, and they should. Log base 2 of 8 is how you say that. And then what other thing did somebody smart learn that we should say? Equals x. Because if it doesn't have it, you should add it. Now you might think that's extra work, but it's not. It's going to help you to solve these problems. Trust me. You want that there. It's your friend. All right. Log base 1/3 of 27. Finish. Equals x. Miss W in the front row. Read this one to me.
Log base
5, very good,
equals x.
equals x. Because you can change these things and simplify them. And you simplified it down to a 5, so I'm proud of you. Equals x. All right, now, how do we solve log problems? It really always comes down to rewriting logs as exponents or writing exponents as logs. So you got to be able to go back and forth. This is kind of one of those kind of examples you'd see in the book. It's all in letters. And I don't know if this is going to work for you, but you got to learn how to transform it back and forth. So write this one down, and I'll explain what it means. I even made it colorful so that you could see like the purple A there, and how the A turns into the base in the exponential. And that blue Y, it starts at the end there, but then it goes to the front. And that X, remember how I said it was the exponent? Looky there, it's the exponent. This purple A is kind of the key, because it's the base, the little number that's shrunk down underneath the log there, and it's the base here. All right, so what does this really mean? This means if I had a problem like 5 equals log base 3, and I put an x here, you'd have to be able to rewrite that as one of these kind. So what I usually start with is the base. The base is 3 to the what in this case? What power? What goes right here? Not x. In my problem, it's this number over here. It's the 5. 3 to the 5. I really shouldn't have used an x. That's going to mess your head up. I'm going to creatively change that to an m for Minnetonka. Log base 3 of m. That way it'll mess up your head less. 3 to the 5th equals m. After a while, you have to trust me that after we've done several of these are going to like start to flow really natural and easy. And it takes a while before that happens, though. All right, let's do a couple more. Let's say I had 5 to the 3rd equals x. How could you write that as a log? Well, if you know what each piece is, this is the base, this is the exponent, and that's the argument. That's the only other word left that we didn't use. Then you should be able to write this as a log. Log, what's the base? 5 of what comes next? X equals what? Notice that I can't stay in order. I don't just go 5 and then write the 3 and then write the x. I got to go to the other side. Log base 5 of x, and then come back for this equals 3. See what I mean? You got to jump sides of the equation as you're writing these. All right, let's try another one like that. 7 to the x equals 12. Write that one for me as a log. And I think you'll see you're starting to get this. Did you say log base 7 of 12 equals x? All right. And just think about what we just did there. We took a problem that we needed to know what number goes here to make 7 to the something equal 12, right? And now I've got an answer. It's right here. If I could only put that into my calculator, and you can. I just haven't taught you how to do it yet. And I don't want to teach you how to do it yet, because once you know how to do stuff on the calculator, you'll start saying, well, why do I have to know the other stuff? And because sometimes you have letters in it, and the calculator cannot find the log of A, but you can, because you can do it with variables. Okay, and the calculator can only do numbers. So it'd be sort of like teaching a little kid how to add with a calculator before teaching him how to add regular. You know what I mean? Then they'd never know how to add. And then when it changed to variables, they'd be like, I can't push A plus B, because they wouldn't know what to do. So I can't teach you how to do the calculator first here. All right, moving on. Let's say I said log base 5 of x equals 10. Rewrite that the other way. This is what you got to be good at, going back and forth between the two. base 5 to the what? 10 is equal to what? So couldn't I do 5 to the 10 with my calculator? Absolutely. 5 times 5 times 5 times 5 times 5. It's going to be a pretty big number, right? All right. All right. You've learned a lot already. Now there's more to know. But I think the smartest thing would be if we got into your homework in the book a little bit. Is there any more I need to do here? You know what? I want to do this one slide here and see if you can understand this before we start the homework, because this is kind of what the homework's like. And then we'll do the homework. Do you get if I rewrite this thing? I'm going to have 13 to the what? 1 is equal to what? So what's x? 13. That's it. So x equals 13. This one, x to the third equals -8. Do you know any way to solve that? Put it to the what? 1/3. And do you know what the cube root of -8 is? I hope so. -2. This one. No, again, your calculator would never be able to do this one, but you could. You could rewrite this as what? B to the A equals C. Okay, good enough. Now let's actually do some out of the book. You're going to need your book. If you don't have your book, borrow one of mine. Leave me a shoe or a cell phone. Make it rapido, por favor. It's off page 308. And yes, I know the tests are still out. I'm going to give you the tests in just a few minutes. I'll pause for a second while you grab books. Log. Base 4 of 4. Is that it? What did I tell you to write after that? Equals x. Everybody do that. And now, how do you solve that? I never told you how to solve it. Yes, I did. I told you how to solve that. Rewrite it, and you'll solve it. That's the same as 4 to the x is equal to 4. And now use your big brain and remember that these have the same base and therefore their exponents have to be the same. And what exponent is right there? 1. And therefore x equals 1. Get that? Because the bases are the same, because this and this are the same, this has to equal this. All right, let's move to the next one, number 2. Miss W, would you read me number 2? Okay, log base 6 of 1. That's how you say it. All right. Equals x. Good. I'm glad you remembered that. And now, Mr. K. And 6 to the x equals 1. There you go. And think for a second. 6 to what power would equal 1? 0. X must be 0. Solve the first two. They involved rewriting and then thinking. Some of you are good at rewriting, but not be so good at the thinking part. Let's do number 3. Back corner. Of what? 30, what was that? I just couldn't hear the number. 32. Thank you. All right, now I rewrite this thing. NN. Do you remember me having you do problems like this last week? And I'd say rewrite the 32 as What? Yeah, same base. So it would be 2 to the x is equal to 2 to the... Do you know what 2 to the what is? Is 32? Fifth. You're right. So then now do I know what the answer is? Yeah. What's x equal to? Get that? You'll need to know a few of those. Like 2 to the 5th is 32. 2 to the 4th is 16. 2 to the 6th would be 64, right? The 2's are really common to have to know. There's even something like the 125 is 5 to the 3rd. That one comes up a lot. All right. Let's keep on going because I want to get to one of these that is kind of tricky. I'm going to actually just go right to it. No, let's just keep going because there's lots of weird ones along the way. Let's do number 4. Log base 381. 3 to the x is equal to 81. A lot of people aren't going to know this, but 81 can be written as 3 to the something. 3 to the 4th, you are correct. That'll answer that one. And that's 3 to the... All right, moving on, number 5. Make sure you're leaving some space. This is not like some competition to try to squeeze it all in on half a piece of paper. Log base 5. That much was easy. But then they got this really weird looking thing. Is there a way you could write that differently? The cube root of 25? 25 to the what? Uh-huh. Now if you do that, and then say equals x like you should on all of them, you can rewrite this thing. 5 to the x equals 25 to the, and do you get how it just turned into one of those problems now? You can rewrite the 25 as a 5 to the something, and now you can get the bases the same. Okay, you should be able to handle it from there. All right, because again, you'd rewrite this part right here as a 5 to the something. And okay, moving on to number 6. Give you some starting help on that one. Log base 6 of 1 over 5th root of 36. Messy. What is that again? The 5th root of 36. I'm hoping somebody in here is smart enough to rewrite that as log base 6 of something nicer than that. It's got to be a negative power, yes? What to the negative 1/5? 36 to the negative 1/5. Very nice. Now, when you say equals x, you can rewrite this thing and you can do your base change thing. 6 to the x equals 36 to the negative 1/5. Now you replace 36 with what? You replace the 36. I'm going to just rewrite the whole thing. Negative 1/5. And then I'm going to erase the 36. And what do you think I'm going to put in there? Then since my bases are the same, you can kind of ignore them. So that has to equal that. That's a negative 1/5 there. You should be able to handle that. All right, and this is the one I really wanted to get to because I never talked about this. What happens if they say log and they don't say a base? That's kind of freaky. It's a good question. Nope, the x is not down there. If you don't see any x, the x is still at the end. What base is... Oh, so what is it underneath there? Sorry, I was looking at the wrong problem. 10 to the 3rd. Sorry. What base is there if there's no base there? There's some logical guesses. 1 is a very logical guess, but it's not that. It's 10. Now why? Because our whole number system is a base 10 number system. Did you know that? Does that make sense? Okay. Now, if it doesn't make sense, just trust me. That base, if they don't show it, that's the most common log. In fact, they call it common log. It's base 10. So if they don't say a base, if there's nothing there, if it just says log, you put a 10. And there's one more kind of a base that you need to know. And it tells you this. Log base something special of 5 will be the exact same thing as ln 5. Yes, log base e. You were waiting for that all along. If it's base of e, that's a very special base. That creates this ln.
So the ln 10.
In this case, it's ln. No, ln means base e. That's the point. Ln is saying it's not a common log, it's a base e. See, let me show you. Log 5 means log base 10 of 5. ln 5 means log base e of 5. So when we get to the ln's, which are coming up, like let's skip to number 13. It's one of your problems. If you want to skip ahead, leave yourself some space and do number 13 with me. Number 13 is ln of e. No, wait a minute. Wait, no, that's not right. Is that right? Oh, yeah, it is. E to the third. And that's meant to mess with your head because there's so many e's running around. I recommend you take any ln and you change it to, what do you think? Log base e. And remember, don't forget the equals x. All I just taught you there was that ln, whenever you see it, means log base e. Okay, so now I can rewrite this as e to the x equals what? And now you know what x is, don't you? Since they have the same base. X must be 3. All right. No, stretch your brain pretty much to the limit here. That's for one day anyway. That's your logs. Otherwise, a word on the street is that the test that's currently scheduled, if you've been looking ahead on the calendar, for Monday, which includes basically what we just went over there, might be moved, but I don't know yet. So, like Monday, like a couple of days, class days from now. I know, it's kind of intense. But we've already learned most of the stuff you'd need for that test. Whether or not we push it a day or not, it's kind of up to the forces that be. Right now, those forces are, Mrs. Richens was the one who mentioned it in the hallway, is saying, I'm not sure the kids are going to be ready for that, and yet she's not the one in charge of this unit, so we'll see what the decision is. But I'm going to teach you like we're going to take the test, and we'll see. All right, so that's enough for one day. Your homework is right there. Remember, the answers are all on Schoology. If you're going to look for them, they're there. A lot of times, teachers handwritten out one. Those are always easier to follow than the book one. But if nothing else, this is chapter 3 in the book. It's section 3.3. You can find it there under the book answers. Okay.